Hello, I'm Norman,
Hi, I'm Daniel.
I'm Nicholas.
I'm Jianming.
and welcome to our capstone presentation video. We are Group 13, also known as the Command Line Module and Low-Level Functionality Group. In this video, we'll go through our capstone project, the good, the bad, the very bad, potential future improvements, and we will probably repeat the phrase command line way too many times. So our client is 11 Engineering, and they collaborated with electrical engineering capstone students to produce a circuit board known as the credit card computer, or C3 board. This C3 board contains their Zinc 2 processor chip, which is based on a 16-bit architecture and has its own custom assembler. Currently, this board doesn't have an operating system, so our group has been assigned the task of creating the building blocks that will eventually form the foundation of this operating system, also known as UAOS, University of Alberta Operating System. The building blocks include a command line interpreter and a suite of low-level routines, which respectively represent direct user interaction and core system functionalities. This operating system will allow for the C3 board to hopefully one day become a single board computer, similar to a Raspberry Pi. That will allow for future capstone students to use it in their capstone projects.
To meet our goals, our proposed system design consisted of two major subsystems, the U of A C3 board and the UAOS kernel. For the C3 board, we planned for it to run the UAOS kernel via its Zinc 2 processor and use GPIO, SPI, or UART to interact with any peripheral devices it connected to, which could be a USB keyboard, a USB mass storage device, a Type-C connected terminal, or an LCD screen. On the other hand, for the UAOS kernel, we planned for it to serve as the main component to implement all our firmware functionalities. It was to do this via two modules, a command line module and a low-level functionality module. The command line module was to use a command handler and library to service command calls from users, and the low-level functionality module was to follow suit and use a low-level routine handler and library to handle calls to low-level routines, such as device drivers. The purpose of both handlers was to detect and service calls to certain functions, while the libraries were meant to actually implement those functions. Now, to showcase the prototype that we ended up implementing in trying to materialize this design, we will play two quick demonstration videos. In the first one, we'll show the command line's capability to recognize and call file system commands via the Type-C terminal, which we were able to set up using a laptop, a USB-A to USB-C cable, and a PuTTY terminal. Then in the second video, we'll show again the same functionality via a working keyboard and LCD screen instead, which were both plugged directly into the C3 using their respective USB-A port and board pins. Yeah. Right, yeah, you can go ahead.
As the name suggests, our project consists of two key components, a command line module and low-level functionality. For the command line module, we were successfully able to implement the key functionality of allowing a user to enter in different text-based commands. In particular, the commands save, load, copy, and scratch are able to be called and print a placeholder output, which would later be hooked up to the file system APIs in the kernel, implementing their functionality. For low-level functionality, our project successfully implemented drivers for USB Type-C connected terminals and USB keyboards. Both of these are translated to UART signals through hardware on the C3 board, and our UART driver is able to work with either of these inputs to receive characters from the user to be passed to the command handler. In addition, Our LCD driver is able to display characters as they are typed by the user through the previously mentioned input interfaces, as well as display the output of commands from the command library. We were also able to implement routines for converting different data types between each other, such as different integer widths and signed and unsigned conversion.
As we progress to our next slide, it's crucial to acknowledge the challenges we encounter. The absence of a working file system on the C3 board limited our ability to implement batch file execution and USB mass storage device drivers. These features are vital for a comprehensive operating system. Additionally, the complexity of implementing floating-point operations within the 16-bit architecture of the Zhang 2 processor is hard to achieve within our project timeline, leading us to abandon this feature. Another major challenge was the unexpected hardware limitations, particularly the incidence of blowing fuses on the 233 board during our final testing phase. This unfortunate event highly reduced our ability to fully test and validate our modules. These challenges, while setbacks, have provided valuable learning experiences and have highlighted areas for improvements in future iterations.
So for future work, there's a bunch of more stuff that can be done. In this semester, there were other 11 engineering projects occurring at the same time, such as the Python interpreter and the SC file system. These are all projects that can be combined with our command line project, as having the ability to call upon these systems from the command line would improve the overall usability of the product and make it easier for future students to build upon. Another area of potential future improvement is the user experience and security. Currently, the command line doesn't display error messages to the user, except if the command is invalid. And this makes it hard to use as you're unable to see what went wrong. Having something as simple as an error has occurred with your command would benefit the overall usability of the system. On the topic of security, the command line and the low-level routines are definitely lacking in secure design. Attacks such as command line injections or buffer overflow are all vulnerabilities that currently exist on the system. Future iterations or improvements on this project should definitely take security into greater consideration. Developing a command or routine plugin system is another area of improvement as well. While the current libraries are modular in design, it still requires a bit of modification to add more commands and routines. Therefore, having a plugin ecosystem for third-party commands would greatly improve the ease of extensibility of the overall system. Another area of future improvement that extends to the entire board system is to add another protocol or communication method. As mentioned earlier, the board supports UART, GPIO, and SPI, which are all fairly relevant communication protocols. But having an additional protocol such as I2C would greatly extend the board's capabilities and would allow for more sensors and peripherals to be attached. Finally, our unfinished areas such as the batch file execution, the USB mass storage driver, and the floating point mathematics are all additional areas for future work as well. As it's already been stated, the reason why we dropped the first two features was because both of them required a file system in order to test and verify its functionality. Without a file system in place, these features were pointless to develop, and that's why we dropped them. However, if a future file system does ever become implemented, these two features, along with the floating point math, should definitely be worked on for the future. In conclusion, our group developed two modules for the 11 Engineering C3 board, one for the command line and one for the low-level routines and peripherals. We succeeded in using the peripheral drivers to connect input devices such as the Type-C terminal and the USB-A keyboard to interact with the command line. Despite the challenges and hiccups that we faced, we were successful in implementing the majority of the project requirements. With these two modules and more, a completed UAOS can be achieved in the future, which will allow for future capstone students to use a C3 board as a single board computer. We would like to thank the following people for their help and support. Hunter Parrish for guiding and leading our group in the right direction, Stephen Knudsen, Wen Tao Xie, and Shyama Gandhi for supporting our group, Steve Drake for helping us with replacing the fuses on the C3 board, and the Capstone Python Interpreter group for lending us their spare C3 board when we needed it the most. Thank you very much for watching.